Okay, so we shall continue from where we stopped previously. So previously we stopped at chapter 3, section A, objective question number 23. I guess this is where we stopped. So we are going to continue from question number 23. Yeah? So sodium react with oxygen to form sodium peroxide. What is the mass of sodium peroxide formed if 0.5 gram of the sodium is completely oxidized? So the question already tells you that they form sodium peroxide. So you must be able to write out the equations where you have 2Na plus O2 give Na2O2. So in here, you can calculate the mole of Na. So mole of Na is 0.50 divided by 23.1. Supposedly 23.1. So I didn't add the 0.1. Okay. Equals to 0.0218. So stoichiometrically, since 2 mole of sodium is to 1 mole of sodium peroxide, so mole of sodium peroxide is 0.01807. So mass of the sodium peroxide in here is the 0.01087 times 2 times 23.1. Sorry, that's supposed to be 0.1 plus 2 times 16, so you get 0.85 grams. Okay, so the answer in here is B. Okay, number 24. The elements radon, francium, and radium has a consecutive proton number. So what is the order of their first ionization energy? Now you need to check this one in your periodic table. Where are the position of the radon, francium, and radium? For information, radon is from group 18, francium is from group 1, radium is from group 2. Okay, so the expected order of from increasing ionization energy. So it's supposed to be group 1, then group 2, then group 13. So your answer should be francium, radon, then radon in here. Okay, so the answer in here is A. Okay, so that is how you should answer for question number 24. Okay, as for 25, which of the following four oxide has the molecular structure as distinct from a giant structure? Okay, so in here Na2O, MgO, Al2O3 are ionic compound, while SiO2 has a giant covalent structure. So in here the answer is donkey D. Okay, then number 26. A mixture of oxide of 2 elements of the third period is dissolved in water. The solution is approximately neutral. So what is the constituent of the mixture? So in order to have a neutral mixture, you must add an acid oxide that dissolves in water. So it is either P4O10, SO3, or Cl2O7, or the basic oxide that dissolves in water. So it can be Na2O and MgO. So inside here, which one has the best combinations in here that makes the solution become neutral? It must be one from acid, one from alkali. So the best answer in here will be C. Okay, Al2O3 is amphoteric and it does not dissolve in water. MgO is basic. Na2O and MgO are basic. SO3 and P4O10 are acidic. So that is how they will not become neutral. Okay, then as for 27, the first ionization energy of the element are shown in the table below. So this is for the period 3. Which factor explains why the value of the first ionization energy of phosphorus is lower than that of the sulfur? So which is in here. So why is it that phosphorus is higher than that of chlorine? So number 1, repulsion between the pair of 3p electrons. So don't forget that inside the valence electrons of the sulfur, it is 3s2, 3p3 phosphorus. And then sulfur is 3s2, 3p4. So in here, 3p is half filled here. Okay. Because 3s2 looks like this. And then for phosphorus, so it is sulfur, it is 3s2, 3p4. So it will be like this. Okay, so inside here, there is an electron pair repulsions between A in here. So that is why it will cause the electrons inside the 3p of the sulfur is easier to this one. So first one is correct for information. Then greater shielding by inner electron is not true because all of them do not have inner electron. Inner electron is more to 3D 4f, those are inner electrons. Okay, so both phosphorus and sulfur don't have that, so no problem on number 2. And then number 3, increase in principal quantum number. Principal quantum number is shell, so they are in the same shell, so number 3 is wrong, not correct. And the stability of the valence electron in phosphorus is greater than sulfur, which is true. excuse me, which is true because phosphorus has a half-filled p orbital. That is why it has extra stability. So the best answer in here is number 1 and also number 4. Okay, so that is how you deduce for question number 27. Question number 28. An oxide of X period 3 dissolve in water forming a solution Y, which is really the absorbed carbon dioxide. So X can form Y because X is what? So X in here is trying to tell you that when dissolved in water form a solution Y, the absorbed carbon dioxide. So it is basically acidic, basic, sorry. So X is basic. So it is an alkaline oxide with a high reactivity and verified by its E0 value, which is very negative. So that is why A, it is very reactive with water, can be accepted. B, it has a very negative standard electrode potential value, which is also correct. So form a cation with a high charge density, not correct, and has many valence electrons, which is not correct. So inside here, the one that tries to tell you that it dissolves in water to forming a solution Y, which readily absorb, shows that it has a very negative standard reduction potential. So the best answer in here is B. Okay. So in here, that is how you are going to solve for number 28. Okay, number 29. Which of the following oxide does not dissolve in water? So in here, very obviously, the one that does not dissolve in water is silicon dioxide because it has a giant covalent structure. Okay, so SO2 when dissolved inside water, it will form SO3. When this one dissolved in water, you form HClO4, and then P4O10 dissolved in water, you form H3PO4. Okay. So that is for number 29. And then number 30, which of the following electronic configuration of elements is most likely react with steam to form water? So in here, it is usually group 2 group 2 as we already learned. Okay, so it is supposedly magnesium okay. So the best answer in here is C. Okay. So magnesium, the first one A is sodium, B is aluminium, D is silicon. So B and D cannot react because B, aluminium is always coated with a layer of oxide, so cannot react with water. D is giant covalent structure, also cannot react with water. So A, no need steam, it can already react with water. Okay, so the best description that describe this one is C. Okay. Okay, D. Element 31. Element D and E are both in the period 3. Element D has the largest atomic radius in the period 3. So that means it is the early position in the periodic tables. So which has a lower melting point than element D. So element D and E react together to form compound L. What could be compound L? Okay, so the question is trying to describe saying that D has a higher positions because D is more left in the periodic table. Okay, so this is the atom for D. Okay, so this is the atom for D. Okay, then that means E must have a smaller atom. Okay. Okay, and then the facts that the second the second fact, it says that it has a lower melting point than D. So in another word, D must have a higher melting point. Okay, so among them, which of the combination is correct? Okay, so let's start from A. What could D and E be? Let's start from A. So in terms of the radius, magnesium is higher, larger, okay, and then chlorine is lower melting point. Okay, so D and E form a compound L, which could be compound L. Okay, so magnesium chloride could be one of them. Okay, then as for magnesium sulfide, so magnesium sulfide also has a higher melting point. Magnesium sulfide has a higher melting point than chlorine. Okay, so it fits the description. Magnesium sulfide has a lower melting point than the element D, so it also fits the description. And then as for C, sodium, it has a lower melting point than sulfur. Okay, it has a lower melting point than sulfur. And then finally, D, so D is the largest atomic radius, the question already said largest, so it must be sodium, okay? So, and then furthermore, chlorine has a lower melting point, so therefore the best one that describes the whole description is donkey D, okay? Okay, so that is for 31. So 32, sodium and sulfur react together to form sodium sulfide. How do the atomic radius and the ionic radius of sodium compare to those of sulfur? So similar to this diagram, if this is sodium, this is sulfur. So sodium has a larger atomic radius than sulfur. So this one correct, this one also correct. And in terms of ionic radius, after sodium donates its electron, sodium ion becomes smaller, while sulfur ion become larger. Okay, so in terms of ionic radius, sodium is smaller, sulfur is greater. Okay, so the best description that describes all of this is donkey D. Okay, so that is for 32. Then we have 33. Each pair consists of samples of two separated elements. Each element is in standard state at room temperature pressure. Which pair of elements has a chemical bond same type between their atoms in here? Okay, so in here, what is the question trying to ask in here is they are going to ask you to describe which one of them has the same type of their this one. So magnesium, aluminiums are metallic bond. Silicon has a giant covalent structure. Phosphorus, sulfur, chlorine are simple covalent molecule because they exist as a multi-atom. And then argon is a monoatomic element. So the best one that describe they have the same type of the forces is their donkey D, sulfur and chlorine. Okay. Okay, so that is for number 33. As for 34, the graph below shows the variation of first ionization energy with the proton number for some element. The elements used are not the usual symbol of the elements. Okay, so this is the P, Q, R, S, T, U, W, X, Y, X. Okay, so which of the following statement is correct? So how to read this transition elements? How to read this one? So that means that from P to Q, this one is from higher period. Let's say this is period 2 lah. So this will be period 3. And then this will be period 4, let's say. Okay. So which statement correct in here? So P and X are in the same group of the periodic table, which is true because they are at the peak in here. So they are supposedly to be from the same group. They are in the same group, not same period. They are in the same group, not same period. Okay, so A is wrong. B, the general increase from Q to X is due to increasing atomic radius. No, when going across the period, atomic radius decrease. So B is also wrong. C, the small decrease from R and S. So R and S is here. So you have to try your best to identify. Is here is due to the decrease in shielding. No, this is due to R has a full field 3s orbital. So that is why. And then D, a small decrease from U and V, which is here, okay, is due to repulsion between the pair electron, which is already explained just now. So the V in here is 3s2, 3p4. So in the 3p4, they are a pair of electrons that are readily to repulse each other, therefore easier to be removed. Okay, so the best answer in here is donkey D. Okay, so that is how you are going to solve for question number 34. Then we go to 35. The diagram shows the melting point of 8 elements with consecutive atomic number. Which element could be magnesium? So now we are talking about melting point. We are talking about melting point. So you have to know by yourself that which group does it belongs to. You have to be very smart in this case. So this is obviously element from period 3. From here, this is the cutting line. Wait. This is the cutting line, sorry. This is the cutting line, okay? So you have to remember well of the trend. This is fluorine, okay? Then this is neon. This is sodium, magnesium, aluminium, and then silicon. So how actually do we tell this? So you have to remember by yourself. Sorry for this. Sodium, magnesium, aluminium increase, then to silicon also increase, then suddenly to phosphorus it decrease. So this is your P4 lah. Then this is your sulfur lah, S8. Okay, so you can more or less tell the trend from where it belongs to if you understand your graph very well. So in this case, it's about how you determine your graph here. Okay, so which one could be magnesium? So the best answer here is donkey D. Okay. Okay, so that is for 35. Then we go for 36. 1.15 gram of metallic element needed 300 grams of oxygen to complete reaction under room condition to form an oxide which contain O2 minus, which could be the identity of the metal element. So molar volume of gas is 24.4. So first of all, you need to calculate the mole, so 0.0123. So since mole is equals to mass over molar mass, so 1.15 divided by 123, so you get molar mass is equal to 94. So since MO is equals to 94, okay, so M will be equals to 78. Okay, so therefore M cannot be plus 2. If this is plus 2 and this is minus 2, okay, so M will be 78. So when M is equals to 78, so it is not inside our periodic table. Okay, so magnesium gone, calcium also gone. Okay, because magnesium is 24.3 ma. Calcium is 40.1, okay? Okay, then you left potassium. Now, if you have M2O, so it will be M2 plus and O2 minus. So if O2 minus, so M in here will be 39, okay? So therefore, the best description that fits this is C, potassium, okay? So you have to consider the possibility of the ion that is formed inside here lah. Okay, so we deduce both of them so that you can easily find your answer. Okay, okay, so that is for question number 36. So the best answer in here is C. Okay, then we go to question number 37. The relative melting point of 4 consecutive elements are given below. Elements all have the proton number less than 20. Which element from the group 16? So as we mentioned just now, the certain drop in here shows that this is for A is for silicon, B is for phosphorus, C is for sulfur, and D is for chlorine. Okay, so obviously the answer that represents the group 16, which is sulfur, is C. Okay. 38. Element D and E are both in period 3. Element D has the smallest atomic radius in the period 3. So there are 2 elements in the period 3 which has a lower melting point than E. So element D and E react together to form L. What could be L? So now this one is slightly a little bit different from the question just now. So element D has the smallest atomic radius compared in the period 3, but that does not include argon, because argon is the smallest. So therefore D is possibly chlorine. Okay, D is possibly chlorine. Then there are only 2 elements in the period 3 we have a lower melting point than E. Okay, so based on the graph, just nice there is a graph here, so you must know that from the graph in here, this is aluminium, and this is magnesium. Okay, for your information, sodium is lower melting point than sulfur. Sulfur has a higher melting point in here. Okay, so there are 2 elements that have a lower melting point. So in here, it is it could be this what? It could be this what? E is phosphorus, and then D is the chlorine. Okay, so the best answer in here is Cl. Okay. Okay, so that is how you are going to deduce the possibility in here. Okay, so the best answer for number 38 is D, because if you look at the arrangement in here, so this is phosphorus and this is the position of chlorine and argon. Okay. Okay, so that is for question number 38. Okay, okay, then 39, X, Y, Z are elements in the periodic tree of the periodic table. The result of some experiment carried out with the component of the elements are shown below. So this is X, Y, Z. What happened when the resulting adding oxide to the water, resulting of adding chloride to the water, and then resulting of the adding oxide to the water. Okay, so in here, X show no reaction with water, so it could be Al2O3 or SiO2. Okay, then the result of adding chloride to the elements hydrolysis. So in here, the one that undergo chloride of the elements, they undergo hydrolysis is more towards AlCl3 and then SiCl4. So both of them can undergo hydrolysis. Okay, and then as for the formation of the chloride, the result of adding an oxide to the acid, because HCl is the acidic lah. So in here, only Al2O3 can react with acid. Okay, so X is Al from here. Okay, as for Y, it forms hydroxide when dissolved in water, so it can be MgO or NaOH, Na2O lah. Okay. Result of adding chlorine dissolved, so it can be NaCl, it can also be MgCl. And when react with the, dissolve only is NaCl, because MgCl undergo hydrolysis. Okay, MgCl undergo hydrolysis. Okay, so NaCl and form chloride salt is Na2O lah. Okay, so the best answer in here, Y is Na. Okay, as for Z, resulting of adding the oxide to the element H2O form acid, so it could be phosphorus, it could be sulfur. Okay, then a result of adding chloride to the hydrolysis, so both PCl3 and also PCl3 will undergo hydrolysis in water to form this H3PO4, H3PO3, H3PO3 plus 6HCl. Okay, you can have that. And the result of the adding element do not hydrolyze, so that means no reaction. So phosphorus fits the description. So this is Z is phosphorus. Okay, okay. So the best answer in here would be A in here. Okay. Okay, so I've already done a table for you to easily check. So hope that you can see clearly the whole things inside here. Okay, okay, so that is for question number 39. Finally, for question number 40, a solid of the element Q react with oxygen gas, compound R is formed. When R is added to water, the pH decrease. So what could be the empirical formula for R? So Q is a solid that reacts with water, so Q may be sodium, magnesium, phosphorus, and sulfur. When added to water, it decreases the pH, that means it is acidic. So on site is only phosphorus and sulfur. So for P, it could be P4O6 or P4O10. Sulfur could be SO2 and SO3. So the possible formula that could be the thing is Q2O5 because it is an empirical formula for P4O10. Okay, so that is for question number 40. So wait, okay, the question asks for empirical formula. Please be careful. So the question is not C. Okay, the answer is not C, sorry. The answer is not C, the answer is B, because the question wants empirical formula. Okay, so with that, that is all for all the objective questions that I would like to share with you. Okay, so immediately we go to the structure question, shall we? Okay. So let's immediately move to the structure questions in here. So structure question number 1, table below shows the color of the universal indicator for few elements when dissolved in water. So yeah, sodium, magnesium, and chlorine. So sodium shows that it is a very basic. Blue color shows that it is basic but not very. And chlorine is red, show that it is acidic. Okay. Okay, based on the color of indicator, state the properties shown by sodium and chlorine in water. So sodium is basic, chlorine is acidic. So we shall learn 1 mark. B, a gas is released when sodium metal dissolved in water. With the aid of equation, name the question 1 name. So please be careful. You have to follow the instruction very carefully. So when the question asks you to name, you better name. So in here, name is the hydrogen gas, and then the equation is 2Na plus 2H2O give 2NaOH plus H2. Okay. Then for C, chlorine gas undergoes disproportionation when dissolved in water. Explain the terms disproportionation. So disproportionation means that oxidation and reduction occur simultaneously on the same substance. Okay. Okay, number 2, write the equation for the disproportionation of the chlorine in water. So Cl2 plus H2O give HCl plus HOCl. Very straightforward. And then state the changes of oxidation state occur in chlorine. So chlorine changes from 0 to -1 and also 0 to +1. Okay, so that is how you get the disproportionation. Okay, okay, so that is for question number 1. So very straightforward, very direct. Okay, let's go to question number 2. Lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, neon are elements in the period 2 of the periodic table. A, state and explain variations of the atomic radius of this element across period 2. So you still use the same factor. We are going to state that atomic radius decreased from lithium to neon. So why? Because nuclear charge increased as proton number increased, while screening effect remained almost constant as electron filling in the same shell. So as a result, the effective nuclear charge increased. So that is why the atomic radius increased. So always remember to use these keywords whenever you're trying to explain the trends of the melting point, the trends of the atomic radius, ionization energy. So always plays around with these terms, nuclear charge, screening effect, atomic radius. Okay. Okay, B, which among the elements has the highest and lowest boiling point? Explain your answer. So the one that has the highest boiling point, melting point is carbon. Okay, while neon has the, because carbon has a giant covalent structure, whereas the lowest melting point is neon. So because it is a monoatomic gas, hold by weak van der Waals forces. So try your best to describe neon that hold by the monoatomic gas hold by weak van der Waals forces. Okay. Okay, so that is for question number 2. Okay. Okay, immediately we move on to question number 3. Are you ready? Okay. Graph below shows the variations of the ionization energy of group 1. So these are group 1, lithium, sodium, potassium, and cesium in a periodic table. So write the electronic configuration of the potassium. So potassium, you have to write full. When they say write the electronic configuration, you have to write the full. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. And B, express the equation for the first ionization energy for potassium. So in here, I will advise you all to add the state of matter because we are talking about ionization energy. So you must add the state of matter. So K gas give K plus gas plus E minus. So that is for how you answer B. Okay, next one is C. What is the valence orbital of potassium? So please, valence orbital of potassium after first ionization energy. So we are talking about valence orbital for K plus. So originally K is 4s1, K plus will become 3s2 and 3p6. But we don't want 3s2, 3p6. We only want valence orbital. So the valence orbital in here is 3s and 3p. So be careful with the terms that they use in the questions and answer accordingly. So teacher, will they accept if I write 3s2, 3p6? No, they won't, because you did not answer to the question. 3s2, 3p6 is a valence electron. The questions want valence orbital. Okay, so 2 different things. D, explain the trend of the ionization energy when going down to the group 1 of the periodic table. So as I already told you just now, so when going down to the group, ionization energy decrease. So since atomic radius decreased down group 1, while screening effect and the nuclear charge increase, screening effect and nuclear charge increase, so effective nuclear charge decrease down to the group. Okay, so these are the keywords. So if possible, don't limit yourself by writing this. You should also add nuclear charge also increase. Okay, so just write that. Okay. Okay, so that is for D. And finally, E. The second ionization energy of potassium is 3070, which is far greater than the first ionization energy. So explain your statement above. So why is it that second ionization energy is far much greater than the first one? If you look back at the tables in here, you can see that the first ionization of potassium energy of sodium is around 420. Do you see that? Okay, so for the second is 3070, so much higher. Why? Because as electron is removed, the screening effect decrease as the number of shell decrease. Okay, so as a result, the effective nuclear charge increase significantly. You must always try your best to also due to octet configuration in K plus. So you should also add this as a statement, just in case if they don't want to accept the answer in here. Okay. Okay, so that is for number E. So hopefully you can understand well. Okay. So that is all for question number 3. Then immediately we go to question number 4. The diagram below shows the atomic and ionic radius for oxygen, fluorine, and sodium. So as you can see in here, oxide ion is bigger than oxygen. Fluorine atom is smaller than fluoride ion. However, sodium atom is bigger than a sodium ion. Okay, so they have different trend. Atomic radius 73, 72, 186, but in terms of ionic trend, 140, 132, 102 in here. Okay. A. Arrange the atomic radius of oxygen, fluorine, and sodium in descending order. Explain your order of arrangement. So atomic radius increase from fluorine to oxygen to sodium. Okay. So why is it like that? Because oxygen and fluorine are from the same period. So therefore, it has the greater effective nuclear charge of fluorine than oxygen, while sodium, it is from the third period, so they have additional shell, therefore it has a greater screening effect. So you should explain as fully as you can. So if I were the student, I would definitely try to add some more word. Okay. Okay, so that is what I would add if I were a student. Okay, and then here the effective nuclear charge of F is greater than the O, since it has they are from the same period where F is towards the end of the periodic table. So that is something that you have to explain when it comes to here. Okay, so don't care where are the marks located, just try your best to write as fully as you can. Okay, okay, so that is for number 4A. Then we goes for 4B. Oxide ion, fluoride ion, sodium ions are isoelectronic. Explain the terms isoelectronic. So what is the terms? So particles with the same number of electrons. So that is for B1. And then B2, by referring to the information above, arrange the ionic radius of oxide ion, fluoride ion, and sodium ion in descending order and explain the order of the arrangement. So in descending, you start from O2 minus, F minus, then Na plus. So it must be, charge must be together. Okay. Why? Because screening effect of these ions are the same, as they are the isoelectronic, or they have the same number of electrons. Therefore, increase the nuclear charge as the proton number increase. Therefore, effective nuclear charge also increase. Okay, so that is the 3 keywords of how you are going to explain why is it that the ionic radius increase in here. Okay. Okay, so with that, that is how you are going to solve for question number 4. Immediately we go to question number 5. Aluminium and sodium are metals of the period 3 of the periodic table. Both elements conduct electricity and react with chlorine to form a white compound. A. State in terms of bonding why aluminium conduct electricity better than sodium. So in here, both of them are whole by metallic bond, but because aluminium has more valence electron than sodium, therefore it has a greater electron to delocalize. Okay. Okay, then number 2, explain in terms of bonding why solid aluminum chloride sublime at relatively low temperature. So when you ever see this kind of the question asked, why does aluminum chloride sublime at low temperature? Sublime means change from solid to become gas. So you have to explain from terms of intermolecular forces. So you have to say that aluminum chloride are simple covalent molecule. If possible, you say that aluminum chloride exists as a dimer are simple covalent molecule and which are held by weak van der Waals forces. Okay, so just write lah. You never know where the marks located. So these are just suggested answer to the questions. So, but as a student, you should be extra careful to write more than you expected. Okay. Okay, so that is 5A, and then 5B, aluminum oxide is an amphoteric oxide. So what is meant by amphoteric compound? So amphoteric compound are substances that can act as acid as well as a base, very straightforward. And then B, write a Valence equation to show the amphoteric behavior of the aluminum oxide. So you have to write the equation. So for example, if you have Al2O3 plus 6HCl give 2AlCl3 plus 3H2O. Now you can also write in the form of the Ionic equation. As long as it is balanced, it should be okay. So Al2O3 plus 6H plus give 2Al3 plus 3H2O. Whereas when you react alkali, Al2O3 plus 2NaOH plus 3H2O give 2NaLOH4. And this is the compound, this is the equation in Ionic, where Al2O3 plus 2OH minus plus 3H2O give AlOH4 minus. Okay. Okay, so with that, I guess that is all for our lesson today. So I'm going to stop at here. So we are going to continue tomorrow with more structure as questions, and also we are going to continue with the essay questions.